Hello there, YouTube. Well, we got kind of an interesting project that we're going to get into today. It's not building a knife, but it is working on some machinery that I'll be using in making of damascus, specifically twisting billets. So I do have a billet twister, but there's always like upgrades you could do to any given technology in your shop, and the time for this upgrade has come overdue. And so we're going to get into upgrading and replacing the parts on my rolling mill billet twisting attachment. Let's go take a closer look. So we're over here in the rolling and twisting corner. Now, currently what I use for a twister is this 1940s Oster Rapiduction bolt threader. It's a lot like a pipe threader. On this one, it holds the dies in the headstock rather than on the carriage here. And you'd grab pipe and a vise in the carriage and feed it into the headstock. I've modified it. Instead of using actually threading dies in here, I make sets of these blank-faced mild steel die blanks for different sizes of square bar, and that just gives me basically a flat, well, a square collet based on the length of these die blanks. The most common one I use is my 1-inch set, and I made a 7/8 set too. And then the vise over on this is actually pretty ideal for this kind of work. It's a self-centering vise. It'll grab up to like 1 3/8, and it's very easy to quickly adjust along the bed, and the bed has take up. It can kind of move along in as the bar shortens up as you twist it and it upsets. So in many ways this is kind of the ideal machine to use for a twisting rig. There are some things about it that are not ideal. For one thing, the bed length could be longer. The maximum bar length I can get in here is about 18 inches. Which, if you're twisting an 18-inch long 1-inch square bar of damascus, you could draw that out into a sword of almost any size. It's a lot of steel. However, the longer you draw a bar out after twisting, the more you wipe your pattern out, so there are trade-offs. The other thing, that this is 2 horsepower, so I can bog it down if I don't have a bar hot enough, or if it's too big or something. It does pretty good on hot 1-inch bar, but still I have bogged it. The other thing is, you know, for a dedicated machine that only does one thing, it takes up this much floor space. And floor space in here is at a premium. It has been at a premium, but it's getting worse all the time. I got another surface grinder coming in soon, maybe another power hammer, so I really got to figure that stuff out. So I do have the rolling mill here. This is a 10 horsepower rolling mill, and when it was built by whatever fab shop, I don't know who built it, but they did an awesome job. It had a twister built into the end of it. The lower roller here has an extended shaft that comes out here, and this collet rig plugs onto it. You can see that's a massively overbuilt square collet that goes onto this 1.5-inch shaft. And then a tailstock is supposed to go in here to provide the other center for the twisting arrangement, but it was not with this machine and couldn't be found when I bought it, so I have to build it. It's been 3 years now, but I think the time has finally come to make this happen. Then I'll have a 10 horsepower, longer bed length, reversible by foot twisting rig that I can kind of collapse, put away when I'm not using it, and takes up less space since I already use this machine for rolling. That's the idea. Woo, this saw is super messy. I need to clear the top off. Not right now. Go ahead and cut this shim. Vise on. Alright. And blade feed. Okay, like that. We'll cool it off. Let's yard this piece out of here. 19-inch long chunk of 4-inch wide by 1/4 inch thick mild steel flat stock. All right, let me see if I can acquaint y'all with the necessities for this next step here. Anytime you're dealing with dimensional tubing, trying to get a telescoping fit inside of other dimensional tubing, you're coping with the fact that very rarely does the outside of the smaller tube correspond to a nice slip fit on the inside of the larger tube. So you're either going to have to cut the outside dimensions of the smaller tube down a bit by grinding or milling or whatever, or you're going to have to shim the bigger tube smaller on the inside. Now, what this has already is a couple of these gibs. They're like a foot long, and they trap the tailstock tube at a nominal 4-inch width. And these are good enough. They're not too sloppy. However, the inside of this is like 2 1/4-ish. So I'm going to put another piece in here for a gib. I cut it 19 inches long because that's the biggest that'll fit on my surface grinder chuck. And at any rate, it's quite a bit longer than these, and it should give a good enough bearing surface. But it's a little bit too thick. So let's see if we can measure what the opening here is with the digital micron. Let's do it at the corner because tubing is often pooched out a little bit in the middle. Do it on the side of the fit there. That is 1.941. Now the square tubing, well, rectangle tubing that I have here for the job is a little bit over 2 inches. So we got to take that into account. I want to get a fairly decent fit so that this tailstock doesn't like kind of droop down when I have it extended far out. So we're going to see what this measures. 2.034, so it's like 34 thou over. Well, no, it's more like past the burr here. It's more like 25 thou over. Okay, 25 thou over, and then for 1/4 inch at the corner, or for 2 inch at the corners, this is again under. So yeah, 9.44. So we're looking at 56 plus 25. Well, let's call it 55 plus 25 is going to give us 80 thou. I need to grind off of this plate before I should start approaching a pretty good fit. So let's do that.
So if we're going to remove 80 thou, that's going to be 8 full passes. Here I'm just taking it easy, finding the surface. There's the surface. Now we'll call that 0. We'll dial back to the start of the piece, and then we'll dial down a 10 thou depth of cut and start our first pass. And then I'll just be chalk marking for every additional pass of 10 thou until I get up to 8 chalk marks, and then we'll take it off and see how it fits from there. Here I'm just going to take a double cut flat file real quick and deburr all the way around the inside edges of this cut piece of 5-inch heavy walled tubing here that we're going to make the collet holder for the tailstock out of. Still surface grinding all the while, multitasking here to get it done quicker, and we have 6 passes done. Here we have a chunk of solid mild steel, 2" by 4" hot roll, a foot long, and we're going to cut this into 3 4" long sections, 2 of them to make the tailstock collet out of, and 1 of them to make the tailstock collet holder support out of. We're just using the scribe and the combo ruler here to mark the first chunk, then we'll saw it and we'll mark the second chunk, and so forth. Over here we got the Marvel 81 hydraulic traveling column vertical bandsaw fired up. Got the flood coolant running. We're going to get this positioned exactly in the vise here. When we do, we're going to lock the vise down. It's a hydraulic vise powered from the same hydraulic system powering the motor and everything else on the saw that feeds. And just the coolant a little bit there, and we're off to the races. That's 1 cut down, 1 more cut to make here, just to create the rough chunks. Second piece marked, going in the saw. Then we'll just take the first chunk we cut off, put it in the back of the vise a little bit to support the off side of the vise so it doesn't rack when we clamp it. Typical kind of a trick there for sawing. The grinder's been running this whole time, and we've just been plunging 10 thou more every now and then as it needs it, and we have finally reached the end of our 8th pass, so we're going to just pull it off with the chuck here and see what's what. Quick deburr here just to get those sharp edges off that the surface grinder kicked up. Back at the saw here, we've just finished our 2nd cut. Kind of fun when you get all these machines going at once. Everything going according to plan so far.
Got all the machines shut off for a minute, so we have relative peace and quiet. Now let's just try this out real quick and see how well it might fit. A little snug. Nothing too obvious, maybe right here. Let's look at this again. Okay, yeah. Right about there. Probably in the middle. Let's see what we can do about that interference. Well, here's where we're at now. I cleaned a little bit of scale off the bottom side of this and put a little bit of oil on it just to see if that would make the difference. The inside of this tube probably has some weld distortion to it from welding these legs on. I wouldn't be surprised if the end of the tube's a little bit wider or like pooched out that way on the bottom because of that. Because it does seem to tighten up once you get about a foot in, which is where this leg stops. Regardless, let's check this out. So I can slide this all the way in and out now. It's a tight fit between these two gibs. And then vertically we still have a little bit of play to take out. But I've got it to where I can get that gib all the way in here. I don't want to bottom it out just yet because it's hard to yank back out of there. What I'm going to do is weld a tab on it like so. Fat tack on both sides, and that way I'll be able to grab a lip and pull it out. And then I'll see, ideally the gib would be on the bottom so that this surface is on the top, and everything just looks tidier and then is kind of, I don't know, dimensionally a little bit neater to figure out for welding the tailstock to this. That's going to be the next step. I'll probably weld tabs on these too. Just got to find the right stock. For some reason I just never have little bits of like 1/2 inch square around and stuff, which you'd think a blacksmith shop would, but I've just been making knives as a specialty for so long I don't keep that stuff in stock. Anyway, I'm going to go weld that, and then we'll see if we can put it on the bottom and make this all work still. Let's try this now. Yeah, it's cooled down enough. It's a little ouchy still, but we don't have to hold on to it for long. Okay. Okay. Well, that looks pretty neat, doesn't it? I don't know, I kind of think I like it like that, with the gib on top there. It's easier to access it, it looks pretty neat. Yep, yanks out of there just fine. Well, let's do that. So with that gib in there, now we can do some other stuff. I'll put this thing up there, and it does have a key, but we don't need to be worried about that key right now because it is a concentric fit on the shaft with or without it. So that's good. Let me just grab a square and a tape measure. Maybe this other piece of stock. Okay, now let's see. First of all, is this guy standing up with its corners 90 degrees to the horizon. It's pretty darn close. So let's measure where that puts the center of this thing. So this is getting from 1 3/4 off the bar to 8 1/8. So 1 3/4 to 7 3/4 is 1, 2, 3, 4, 5, 6 inches, and then we're going to add 3/8 more, 6 3/8. Total point to point, sitting 1 3/4 off of here. Well, 6 3/8 divided by 2, that's 3 3/16. So the center of this is 3 3/16 above 1 3/4. So 1 3/4 plus 3 is 4 3/4 plus 3/16 is 4 15/16 to the center of this collet, the true center of this 5-inch tube, not the collet which is sitting in there sloppy. The theoretical center of the collet where it concentric. 4 15/16 off of this tube. So that's the measurement that we'll use to establish the height of the tailstock here when we're welding that to the end of this bar. I'm going to do it on the diagonal. Why? Because it looks cooler, and because I'm going to actually make a pass-through slot here that'll be kind of easier to access, and because darn it, I'm used to twisting on the diagonal rather than like flat. Yeah, it would be a little bit easier to fit it up flat, but we ain't necessarily all about easy here. So let's go ahead and figure out what we need to cut in here to stand that up enough and weld it on. All right, we're gonna do this kind of seat of the pants engineering style, because this ain't no precision assembly. We just need like anywhere from a 32nd to 16th precision. These two chunks are for the collet. This remaining chunk is for the rear tailstock support. This is going to connect the actual collet holder, the 5-inch tube, to the bed of the twister. Yes, it's massively overbuilt, but everything else is, so I figured I would just stay with the theme. So this has one end from the steelyard and one end that I cut when making these. I think my cut is straighter. Let's see. Yep, that's their cut. Here's my cut. We got about a 32nd of rock there. Checking it on this side, it seems even a little better. I'm going to call that square. Now, let's go ahead and find the center. This is, again, 4-inch stock. Might be just a skosh undersized. That looks like the center to me. Let's make a little bird's beak there. And then let's make a bird's beak in the middle on the other end of the stock. And connect the two. I would much rather do that than like rely on the end of the stock and on the square to transfer up a center line. Now I'm gonna put this on one of my bird's beaks. I gotta sharpen this damn punch. All right, let's try this again. Sharp scribe this time. Got that on there. Visually align it with the other one. And the ruler actually likes that. It also thinks that's square. Bro, this thing just got dull again. Yeah. Let's measure up 1 3/4 from the bottom of this. Make a mark there. And then let's scribe a line across there. That's where the bottom corner of the 5-inch tube will have to sit. Yeah, now let me set this square for 45 degrees. But we could do this using Q-tapes basically. Put this on here, put this on here. We're at 6 3/8, so we need to be 3 3/16 with this when we're at the center. We'll slide it down until we are right on the money there. Mark. Mark. Yeah, that looks good. All right, now we'll plonk it on here. I'll get one of these involved and just prop it up on the backside with that. Nice to have a few blocks of the same size here. And I'm going to take this and we'll just scoot this until it's 45 degrees to the edge of the block and sitting right on our 1 3/4 baseline. We'll check it from both sides. Yeah, that looks good. So this is telling me where I need to cut my notch. And I had to do it this way because this stuff doesn't have a sharp point on the outside. It's got a theoretical point. And our dimension off of the twister bed was not to the theoretical point, it was to the actual point. So I had to figure out how to make the actual point be 1 3/4 off the bottom of this block while showing the actual point on the block as well, so I know where to run the bandsaw to, because we're just going to put this on the bandsaw bed and cut it out. And then we have our notch marked out here that this is just going to sit down inside of. We'll just cut a nice 45-degree chunk out of here. Now that the block's not in the way, I will extend these lines all the way up to where we need to actually start our cut here. Boy, this block's got some gnarly scale on it. It don't hardly want to scribe. I'm gonna go buy a new carbide scribe tomorrow. This thing ain't working for beans, a steel one. Okay, I'll just finish this line. I can't even see that. Let's get that out of the way. Get our angles where we actually have light on the line. All right. Okay, so all that's getting notched out. One of the coolest things about this saw, I could just roll the saw bow over and set this up differently in the vise and use the 45-degree feature of the tilting saw head to actually get this angle. Or if I just want to saw stuff flat, I can get whatever angle I want without having to tilt the saw bow. With the use of the fixture plate here, it's got some tapped holes in it. You can always pop more holes in it if you need more for a particular job. I use this one a lot for ripping damascus, so it has holes along the edge. You can use some of your toe clamps from the mill, and you can just orient this however you want, clamp it down, grab the entire fixture plate in the vise, which opens real wide, and then track your blade up to the cut. And since you're starting on an angle, you just need to let the blade barely coast into the cut to get it started so it doesn't deflect, and then you're good. We'll just cut up to the line, then we'll turn it in the block, grab it here and here, and then cut to there. So let's get after it.
Here I've coasted the saw up right to the stock and stopped the feed, and now I'm actually pulling the saw in by hand a little bit till the first like 1/16 of the cut has been started, and then I'll trust actual feed pressure to the saw, and I'll know that it's not going to deflect with the feed pressure. First cut's done, right up to the line. Second cut proceeding apace.
And here is the desired result. Nice, clean 45, well, 90 included angle. That was the top of the cut. There's the bottom of the cut. It meets up perfectly. We'll set that guy in there. That's a nice fit for that 45. No gaps, except at the bottom where there would be. And let's see here, we got about a 32nd above 1 3/4. And there we've got 1 3/4. So we'll call that good. I am going to go ahead, grind scale off of here all the way around where it needs to get a weld. I'm going to grind heavy chamfers in all the way around this so we can really get a good strong weld in there. Then I'm going to cut chamfers on this all the way around. And we'll probably do a couple of passes of weld around, all the way around the foot of this to get it onto the bed of the twisting attachment. But we're making good progress. I'm gonna go inside and eat dinner for the night and put the kids to bed, and we'll wrap this up tomorrow. Here are the parts mocked up so you can see how it's all gonna go. Pretty simple. Now this collet is made out of these two pieces of 2x4 solid, and each half had a recess milled in the center, 1/2 inch deep by 1 inch wide. Then when they were put together, welded together here, it formed that 1 inch square collet. I think they really missed an opportunity here. One side of this should have been inch like this, and the other side would have been either the next size up or the next size down, 7/8 say. And you could have had 2 collets for the price of 1, and that's not an inconsiderable price with that heavy of stock. So yeah, this one is going to be a double-sided collet. I'm going to mill one side for 1 inch, and I'm going to put that feature half the length of the collet, 2 inches. And then I'm going to mill a different size collet in the other size. Might go with 7/8, or I might, yeah, I'm just going to leave that one as is. I don't want to crack it apart. I'm going to go with 7/8, and then the next collet that I build for this size will be 7/8 on one side and maybe 3/4 on the other. And then we'll just build more as we need them. Anyway, so what I have remaining to do, I got to weld all this stuff together, chamfer and weld it out. And then these two I got to take and mill the step in each side for the 2 different sizes of square collet that it will become. Okay, so this is the leading edge of the collet holder. This is the top corner. So I'm going to put a feature in on this side that I think is going to be helpful. We're going to make that 1 inch deep there. Let me just adjust this some. Yeah, 1 inch deep by 1.5 inches wide. So first we're going to mark a line across. This big, heavy square tube doesn't have enough of a corner for the combo square to really catch well here. So I'm measuring it from the end of the cut. So yeah, 1 inch off this edge. And then we're going to make a center line. So boom. Well, let's just skip that part. It's going to be 1.5 inch wide feature. We'll go 3/4 to each side of the center. Right there. And then we're just going to scratch a line out to the edge from there. I could explain what this is going to be about in an abstract fashion. It might be easier to kind of understand it when it's done and installed on the machine, but basically this is a drop-in slot for the billet end. You don't want to have to work overly hard wrestling a billet in and out of this when it's hot and you need to be twisting it right away and you're losing heat if you're not getting into the collets quickly. So what I'll be able to do if I cut this slot out is I'll be able to pull the collet back out of the holder a little bit. I won't have to position this actual holder in the bed of the machine. I won't have to adjust the bed length. I could plug the one billet end into the headstock, swing it down. I won't have to pull this entire assembly back, bring the billet in line, and then push it forward to get the billet into the second collet. I'll be able to drop the end of the billet through this little slot with just the collet pulled back in the holder, and then shove the collet back flush with the face of the holder and catch that last inch of the billet to hold and twist. 1 inch is about all you need. Any more than that, you're just wasting good steel anyway. And if I ever need this slot bigger, why, then I can cut it bigger, but I don't really envision twisting stuff bigger than 1.5 inches anyway. So we'll probably remove that with, we'll drill holes here at the corners and then cut up to it with the angle grinder. And maybe creatively notch it out there, because we can't really bandsaw it. We're not putting an opposing feature on this side. So we'll see about that. The other thing we got to do is chamfer this guy. This is the inboard side, so I'm just going to mark that real quick. And then we're just going to take and cut chamfers all the way around where it's going to weld to the square tube of the holder. And then around the bottom where it's going to weld to the square tube or the rectangle tube of the bed. So we'll get better weld penetration with the big MIG. The other thing that we could do too, with that being the inboard side, this being the top, is we could take and trace around here where we're going to want to remove the mill scale from the square tube. Just grind it clean, so we also get our weld actually sticking better to this material. There we go. So now we're just going to do a bunch of grinding with the belt grinder and angle grinder and such. All right, so we're gonna do this way. I've got the mill in high gear, and I'm gonna dial it down to about 700 RPM. We're gonna drill the corners, and then we'll do like maybe a row of holes and then we'll just finish it with a an end mill to get nice straight sides.
You may be wondering why I'm not starting these holes with a center finding bit. If your drill bit is sharp enough and you start your hole without very much pressure, just kind of touch down and very lightly make a mark when you start drilling, generally that bit won't blunder and it'll make its own center punched start in effect. Something to think about. So off camera there, I took it over to the anvil and bashed that piece out with a ball peen hammer. I had to nick the leading edges a little bit with a bandsaw and then everything popped out just fine. Here we are with a 3/8 2-flute end mill, just gnawing off the little remainders of the web there. And we'll just work our way around the perimeter and clean it all up.
Okay. That'll work. Get that out of there. Of course, it's covered with ouchie slivers. Slot it out. And we'll just have a quick deburr at that slot real quick. Before everything gets smoking hot and jigged up for welding, and then later kind of harder to get to. Just a light deburr with the file here. Hey. There we go. Good. I'm going to set up and do that weld. I like it. We'll just wire brush that off real quick. So here's how those welds came out. Now this is still pretty hot, so it's actually got a good preheat. I'm just going to weld it to the rectangle tube now. Let's get this locked in there good and tight. That's interesting. It wants to kick up a little bit when I clamp on it. It's like the sides are a little bit parallelogram. Great. Imagine that. Let's swap it around here and see if it does any better. It wants to kick up on the other side now. Whatever steel mill here didn't do a great job of truing up this dang stock. Oh, what a pain. Am I really gonna have to mill the sides of these true? No, I'll lose some dimension. Maybe I'll throw them on the surface grinder. We'll see. So, fun stuff. Look how far out of square this stock is as hot rolled. Almost a 1/16 out of square there, probably. This side is not quite as bad. Maybe a 32nd of rock in it there, so unfortunately I'm gonna have to mill at least one side of this stuff off if I even want the mill vise to be able to grab it from the sides. So let's see how out of square this one might be. They came out of the same chunk, so I'm assuming we got the same situation here. One side's probably worse. This side's worse, right? So that's going up and it's getting milled off. I'm gonna make sure the acute side is running out the same direction on both of these. Okay, that's facing in. And then this one, it's facing out. So I'll turn that around. And that's facing in now too. So put those in the vise. I'm gonna try to grab these guys side by side, like so, in the vise. And I'm gonna have at them with the face mill here. And we are gonna take these down to having a 90-degree side to the flats here. Then we'll be able to grab them in the mill vise. I'm gonna have to recheck my width on them, and we're gonna have to recenter find them. I won't make you guys watch all that stuff, but we will watch this real quick. So 30 thou depth of cut there. I've got a little bit of scale left on this corner, but I think that will have sufficed in getting us a square enough side that these will clamp in the vise now. I don't want to take too much off the width because that's just going to make them fit sloppier in the holder than they already will. So let's try clamping one of these and see if it behaves a little bit better now. And then let's see, where is, okay, yeah, so we want the acute corner on the bottom, so we'll put it like so. That ought to make it, I want to suck down, if anything, rather than kick up. But let's see if that's true. Oh yeah, we're good to go now. Good stuff. All right, we'll take out the old face mill here. come on. And then, yeah, we'll put, well, okay, right, so, told you I wasn't going to make you guys hang out while we do this again, but won't take but a second. 3.955. Let's round that up to 3.960, so we're 40 thou shy. So now we're going to be 20 thou off of short of 2 inches when we dial off the back jaw to our center. So still not too awful bad. 20 thou off. So let's get our center finder and our collet to run that dude in. Oh man. Huh? All right, let's find that back jaw. Okay, we got that. Put this dude away again. And right, lock table, reset 0, unlock table, dial back 250, lock table, remove run out, reset 0, and then we're going to dial, what did we say, 20 thou short of 2, so 1 inch 980 thou, so 1, 2, 3, 4, 5 gives us an inch, 1, 2, 3, 4 for 80, half a turn for 90, or for 900 thou, and then we're going to need to come up to 180 thou on the dial. And that should put us on the center of this guy. Lock the table good. And then let's chuck this guy up. And yeah, we're going to keep this spinning at about 300 RPM. And we are going to find the surface and then take a 200 thou depth of cut, mill our way across. I don't have a coolant set up for this guy right now. Wish I did, but it is what it is. Whew! Alright, well, there's one pass at 200. It just kept cutting fine. If I fed it too much, it would chatter a little, so you back it off. I'm going to vacuum up all these chips. I'm going to take another pass at 200 depth. Take the finishing pass at 0.375. And I'll pull you guys back and have you watch when I'm cutting the second side for the extra width. I need to get some anchor lube or something I could at least just brush on here. I'm gonna order some tonight because I just don't like cutting that dry. Okay, we got the 1-inch side of the slot milled out too now. Let's see how we did. Where to put that file? Let's use this file. The 1-inch side, the 7/8 side, the difference right here, and now we'll just make sure that the other one, when we mill it, isn't offset to this anyway. I think we have this milled right in the center, but we did mill one side more square, so we just need to make sure that we're not flip-flopping that when we mill the other one. Pull you guys back when we get it done. So we have the one block, and I figured something out here. I don't know why it didn't occur to me earlier. These collets are made up out of 2 blocks put together face to face, or side by side if you like, and they have square holes formed by 2 halves. So we can have a different size in each end. 7/8 inch, right? Well, these collets are not only 4 inches long, they're nominally 4 inches. It's a 4-inch cube. So why can't we have a collet here and a collet here as well, and have 4 different sizes in the same block? That seems pretty cool. So I think ultimately what I'll have with these is I'll have one side be 7/8, one side be 1 inch, one side be 1.25 inches, and one side be 3/4. Those are the sizes I'm most likely to be twisting with these. That way I can make the already existing collet. I could crack it back apart, you know, angle grind the welds out. And it's 1 inch all the way through, but I could mill the one side out to 1.25 inches. So I'll have 1 inch and 1.25 inches in that block, and then I'll tumble it and do 7/8 and 3/4 in the other 2 sides. It doesn't matter if the blocks are identical in terms of, you know, 1 inch and 7/8 are opposed to each other. The other block would have 1.25 and inch opposed to each other. The important thing is I'll just take punches and I'll mark 1.25 inch, 3/4. I'll mark them for what they are, and that way when I tumble them in the holders, I'll just know when I have a matching set. So in the future, I'm going to do that. Right now, I don't want to do all that milling, and I don't have plans to twist 3/4 inch or 1.25 inch bar right now. Inch is by far the most common size that I twist at the moment, followed probably by 7/8. So that's the 2 sizes that I'm putting in this block. I'm not even going to crack the other block apart and then cut a 7/8 side into it yet. I'm going to do that down the road. Right now, I'm just getting this thing made, and then when I have plans to twist different sizes of bar as the need arises, then I'll mill the features into them. All right, here we are on our 1-inch side. Got everything deburred, rounded out a little bit so it's easier to slip a hot piece of steel in there. If that side is good, I'm going to flip it over and deburr the other side. Get that all situated just like we want. And there's our 7/8 side, deburred and rounded a little bit. Now we'll just chamfer a little bit where some welds are going to be. Cool. That way we'll have hopefully just a little less fumbling around in future times when we have multiple collet sizes on each block that we need to find. 7/8. Here we are, collets. Going to go in the holder for the first time here. Okay. Well, that looks like so. You know, I got power to the roller, so it'll be like that, or we can reverse it. So that's cool. Bump it a little bit, get them aligned here, and then let's see. So this slides in and out snugly, but easily enough that it's manageable. And I don't know what the max distance between centers is going to be here, but quite an improvement upon my smaller machine. It's probably around maximum. Let's see what that is. So that would give me the ability to twist about 2 feet between centers, whereas the old one was 18-inch max. And that's counting the ends on that machine. I could put a, like a 27 or 8-inch. Yeah, a 27-inch bar in there probably. Might be able to twist longer than that. How much is this sticking out? Oh yeah, I could probably pull that out of there another 4 inches. So I bet you I can get a 28-inch long actual twisted bar between these centers. Only thing left to do now is test it. I'm gonna stop. Did I stop? Yeah. It'll just keep going. That is crazy. Man, that thing shortened up by, a couple inches and fattened up by 3/8. Cool. That machine didn't bog at all. This thing's cooling down a little bit, but bro. I mean, that thing is twisted up. And it would have just kept twisting on that until it just sheared it in half easily. And this is pretty high carbon steel. I don't know what it is, but it's spark high. And this stuff just treated it like noodle dough. Cool. Well, guys, I'm gonna call that an absolute success. Couldn't be happier with that. Now, thanks so much for checking this here video out and keeping me company in the shop. while I went through all this milling and fabricating and stuff, we've got ourselves a pretty useful tool here, I would say. And I'll actually post it twisting some damascus before too long, I'm sure, in a future knife build video. That's all. Catch you next time.